Hey guys, welcome to question MM403 of the Maths Methods Fortify study guide. So at this particular restaurant, it's known that 70% of customers will order a drink with their meal. If 3 customers are chosen at random, what is the probability that A, all of them ordered a drink with dinner? Awesome, so this is just a 1-mark question. We don't have to show that much working, or any working actually, just the answer. So if we know that 70% of them order with a meal, and we're looking for the probability that 3 customers order a drink with their meal, then we can simply say that it's a 70% chance that the first one orders a drink, then a 70% chance that the second one orders, and a 70% chance that the third one orders, right? Which means that each of these probabilities is 0.7, which means that the probability that 3 of them order a drink is 0.7 to the power of 3, right? So it's 0.7 times 0.7 times 0.7, but we don't have our calculator, right? So I would prefer to do this in a fraction form, and because we don't have a cas, it's implied that we would answer it in fraction form, exact form. So I would change this to 7 on 10, because 0.7 is 7 on 10 to the power of 3, which is 7 to the 3 over 10 to the 3. 7 to the power of 3 is 343, and 10 to the power of 3 is 1000. So therefore our final answer is 343 over 1000. That's our first and only mark for part A. Let's move on to part B. Part B asks us to find the probability that exactly one of them ordered a drink with dinner. Alright, awesome. So this could be the first one ordering a drink and not the second one, and not the third one, or the second one ordering a drink and not the first and third, or the third one ordering a drink and not the first and second. So there's 2 ways we can do this. We can use our binomial formula, which I think would be quicker, or you can use your tree diagram and then add all the things together. So have a go at using your tree diagram if that's the way you're comfortable with, but I'm going to use the binomial distribution formula here. So the binomial distribution formula says that the probability of x equals x is equal to ncx times p to the power of x times 1 minus p to the power of n minus x. And in this case, our x value is 1, right? Because we're looking for the probability that exactly one of them ordered a drink with dinner. So our n value is 3, because that's the amount of people that we've taken. That's the sample space. So 3c1, because our x value is 1, times p, which is our probability of success, or our probability that this person orders a drink. So 7 over 10, because that's our 70%, to the power of x, which in this case is 1, and then times 1 minus p, which is 3 on 10, to the power of n minus x, which is 3 minus 1, which is 2. So this is our first mark out of a 2-mark question. Simplifying this, 3c1 is 3. So whenever you've got like 3c1, it'll be equal to 3. If you've got 10c1, it's equal to 10. So it's whatever this n value at the top is. 7 on 10 to the power of 1 is just 7 on 10. And 3 on 10 to the power of 2 is 9 on 100. Now simplifying this even further, we get 3 times 7 times 9 over 10 times 100, which simplifies to 189 over 1000. And we will leave this like this because that's in exact form and we don't have a calculator. So that is our final answer, 189 on 1000. And that's it for MM403. So guys, if you have any questions, as always, please hit me up in the comments below. But otherwise, thank you for watching and I'll see you in the next video.